Let's jump right into this explainer. Today, we're unpacking the ultimate roadmap for moving beyond just superficial technology so we can actually start building the future. Welcome to Circuit Minds Decoded. Look, you interact with technology thousands of times a day, right? Tapping screens, asking digital assistants for the weather, relying on crazy complex algorithms just to navigate traffic. But for most folks, modern tech is just this magic black box. You press a button and boom, something happens. But since you're here, I know you've got that itch to pull back the curtain and figure out the actual wizardry inside. So we're going to crack that box wide open together. We are officially moving from being just passive consumers of technology to becoming the architects who actually build it. We'll kick things off by asking the big questions that really ignite our curiosity. Like, have you ever stopped to wonder how a tiny, dirt-cheap microcontroller, something you can literally balance on the tip of your finger, can command the incredibly complex physical movements of an entire robot? I mean, it totally seems like magic until you break down the underlying engineering. It's actually this fascinating translation process where digital logic, just simple ones and zeros, gets converted into physical electrical voltage. That voltage then pulses into a servo motor at exact intervals, telling a mechanical arm to rotate, say, precisely 30 degrees. Suddenly, it's not magic at all, it's just brilliant, perfectly understandable physics and code working in total harmony. Or maybe you've been wondering about the invisible logic behind the software curtain. Specifically, how does artificial intelligence actually learn? How on earth does a machine go from a blank slate of code to recognizing complex patterns, translating languages, or even generating original art? Well, think of it kind of like a human learning to recognize a dog. A toddler doesn't sit down and read a rule book about dogs, right? They just see hundreds of examples until their brain finally just gets it. AI works in a really similar way, through neural networks. We feed a program thousands of images, and with every single image, it slightly adjusts millions of internal mathematical dials, almost like digital synapses, until it can perfectly spot a golden retriever. We're going to look at the exact ways these models are trained to think and adapt. And what really happens inside your computer the millisecond you hit that power button? It's basically a beautifully orchestrated symphony. Your motherboard's BIOS wakes up first, firing off a power-on self-test to check the hardware heartbeat. Once it confirms your RAM and processor are alive and kicking, it hands the baton over to your operating system, which finally loads your desktop. Knowing this exact sequence is incredibly empowering. It completely removes the fear and frustration of troubleshooting your own machines. These are the exact mysteries we're unraveling in this explainer, transforming all that confusion into clear, structured engineering mastery. No more guessing, just pure, practical understanding. So, here is our blueprint for today's journey. First, we'll cover the Circuit Minds philosophy. Second, decoding hardware and electronics. Third, exploring AI and future tech. And finally, number 4, building projects and community. Let's jump right into our first section, the Circuit Minds philosophy, and how we start moving beyond the surface. Now, this core philosophy is what truly sets engineers apart. On one side, you've got passive consumption, just knowing what a technology is. This is the person who camps outside a store for the newest smartphone just because it has a fancier camera. That's surface-level trivia. But on the other side, we have active mastery. This is the person who understands the silicon architecture inside that phone and exactly how a tiny image sensor turns photons into digital pixels. This is our true focus here, understanding how it works and why it matters. We're totally abandoning the habit of just watching tech happen. Getting to that active mastery changes the way you view the entire world around you. Now that we've got our mindset locked in, let's explore the physical foundation of our curriculum in Section 2, Decoding Hardware and Electronics. We are going to systematically break down the physical building blocks of our world through a narrative of scale. So we start at the microscopic level with semiconductors, really understanding those silicon wafers carved into the tiny chips powering absolutely everything. Then we zoom out to the circuit board sitting right on your desk, covering basic electronic components like resistors and capacitors so you can build your own designs. Zoom out again, and we decode full computer internals, unpacking how the CPU actually talks to memory and storage. And finally, we scale all the way up to robotics, taking those tiny chips and circuit boards and giving them wheels, sensors, and the ability to autonomously navigate their physical environment. So, the really crucial point here is mastering this specific intersection, embedded systems. This is exactly where software meets hardware to create smart devices. Just think about the anti-lock brakes in your car or the precise timing mechanisms in your microwave. Those aren't just dumb mechanical parts, they're embedded systems where code is constantly making split-second decisions to control kinetic energy and heat. It's the literal bridge between digital thought and real-world physical action. If you want to understand how a line of C++ code makes a heavy industrial motor spin safely at high speeds, well, this is absolutely the most powerful skill set an engineer can possess. Building on that robust hardware foundation, let's see how this all connects to the advanced software shaping our reality in Section 3, Exploring AI and Future Tech. We're going to dive deep into these cutting-edge domains to really grasp the innovations transforming our world right now. We cover artificial intelligence, focusing heavily on machine learning and how to actually train your own models. Next up is the intricate world of cybersecurity, where we explore ethical hacking and network defense. And finally, the wild frontier of future tech. This encompasses the Internet of Things and incredibly exciting fields like Edge AI and TinyML. And hey, this isn't just buzzword soup. Edge AI literally means taking the massive brainpower of a huge cloud server and shrinking it down onto a chip the size of a coin, so your devices can think for themselves without even needing an internet connection. Mind-blowing, right? Now, what's really fascinating here is our approach to ethical hacking and cybersecurity. We focus on securing systems by thinking exactly like an attacker. Imagine a master locksmith for a second. They know every single vulnerability of a lock, and they know exactly what tools are required to pick it. That is precisely why they're the only people qualified to build a lock that cannot be picked. You can only truly protect a network once you deeply understand how someone might try to exploit it. It requires a complete flippant perspective, and adopting this hacker mindset is, honestly, a thrilling way to study software architecture. All right, it's time to shift gears from the theories we'll study to the actionable steps we'll take to bring this knowledge to life. Let's dive into Section 4, Building Projects and Community. This actionable framework ensures we're never just passively watching a screen. Let's walk through a hypothetical example. Say we want to learn about environmental sensors. Step 1, we explain the difficult concepts clearly with animations, visualizing exactly how a thermistor reacts to heat. Step 2, we immediately apply that knowledge to build a practical project, wiring that sensor up on a breadboard. And Step 3, we solve a real engineering problem by writing a script that reads that data and automatically triggers a greenhouse ventilation fan. See the flow? We visualize the complex concepts first, and then we immediately get our hands dirty applying them. To support your journey from a curious hobbyist to a confident, aspiring engineer, we'll also be supplying these critical resources. Why? Because mastering engineering requires deep work and immense focus. That's exactly why we provide productivity tips and curated tools to keep you on track. We'll offer detailed learning roadmaps and career guidance because, let's be real, this isn't just about tinkering on weekends. For many of you, this passion has the potential to become a highly lucrative and fulfilling profession, and we want to ensure you have the exact blueprint to get there. And that brings us to the ultimate motto of our channel, the core of what we're going to learn and do here. We'll learn together, we'll build together, we'll grow together. This explainer, and quite frankly, everything we do, isn't just some one-way street of me talking at you. We are building a collaborative hub. Your ideas, your specific hurdles, and your curiosity in the comments will literally become the blueprints for the projects and technologies we decide to explore next. Since this is only the beginning of our engineering journey together, I want to leave you with this final thought to really spark your own innovation. What technology do you want to build next? Is it an automated smart home hub? A custom drone? Maybe your very own trained neural network? Think about it, visualize it, and let that vision drive your learning. Thank you so much for joining me for this explainer. Now, let's get to work. I'll see you in the next one.